coming again to the borderline between medicinal chemist and process chemist. The medicinal chemist looks to the physical chemical parameter of your molecule. It looks to the molecular weight. It should not be too high. You have to have a certain pKa. You should have a certain log P value. And you look to the polar surface area, because depending on the polar surface area, you may not be able to enter the brain. Bad thing. And you know the 3D structure of your molecule, because this 3D structure in the end determines how your molecule is interacting with the protein. Important to know. And of course you know a little bit about patenting, because it should be a new molecule. Because if it has been described before, bad luck. It's not an invention. And you of course know about toxicophores. So there are some functional groups you don't like to have that much. So nitro maybe not the best. Also some phenols maybe not that great to have. So that's something you have to have in your mind and when you design your molecule and when you actually prepare it. And then you get the answer. You get the answer from your biological colleagues telling you, well, you have an active molecule, but sorry to say it's not entering the cell, so go again and get some new stuff. So that's actually what's ongoing here. So what is actually the dynamic of the molecule? So what is actually the effect of the drug on the protein level, on the cellular level, on the body? Or what is the body actually doing to that? But we have something in common with the colleagues in process chemistry. We are still synthetic chemists.
Okay. If you can see, there's quite a bit of difference in the keywords in here and in keywords in here. First time I was asked to do the presentation about the difference, I felt like I have to compare apples and oranges. They both round. That's it. But we're looking at different things. The price of the starting material, safety, of course. Waste does cost quite a bit of money, and if it's aqueous waste, do we have to burn it, or can we just put it in the water waste treatment facilities? And of course the campaign times and throughput times. Sometimes your reaction is 1 hour, but the isolation procedure and the reactor wash, that's 12 hours. So that has a high, this is a very impact factor. Also the batch size, because of the validations, you have to have an idea what is your true batch size for the API, or the annual requirement for the API, because once you log this, you can't change it. Because after that you have to revalidate and re-registrate your process again. And of course the main one biggest issue is like you got to look at the final API. What is is it crystalline? Do you want the amorphous? What is the polymorph you want? Because of course we saw the presentation from Wim. There might be over 10 different polymorphs for one compound, and also the solvates. And of course the particle size, what we're looking for. And all of these impact eventually to the price of the API. So I prepared one slide what is process chemistry. Of course we had Wim's nice lecture, but we're